A very important question to be able to figure out in the world of networking is what happened or what currently is happening that's causing a problem. And a great resource that we are going to turn to over and over again are log files. So let's chat about logs for a moment. Most devices generate some local logs. I know multilayer switches do, routers do, access layer switches do, Windows servers do, Macintosh systems do. Although that doesn't look like a Mac. Linux systems do. They create logs. And an important thing to realize is that if there are problems, it's usually the log files that will tell you exactly what's going on if we know which logs to look at, and also if we have accessibility to those logs. So in many organizations, they're going to have a centralized logging server. And then we can train all the devices like routers, multilayer switches, servers, other critical devices that we might have to send that information over to the logging server. Some examples of this would be an SIEM, and a basic example of a logging server would be syslog. And one of the benefits of having everybody send their syslog messages over here to the logging server, even if they have them locally, is that we have a central location that we can go in and look to see what happened. So a syslog server can help us aggregate all the logs from multiple devices. And if we have a user that's trying to access some resource and they can't get there, we might go to the most likely log file for the device that denied it. Maybe we have a firewall right here between this router and the rest of the internet. And maybe this firewall is doing URL filtering based on categories of URLs. And so if this user can't go to one specific website, but can get to everything else, that's a very good candidate that we should go to see whether or not that specific device, that firewall, and its logs are reflecting that it's dropping the traffic. So as an example of logging, let's bring over a router. I'm chuckling because this is this SP to internet router. Let me change the host name back. We modified it in the SNMP video. So I'll specify host name is going to be SP to internet. All right, so let's go ahead and take a look here at the logging on this local device with the show logging and press enter. So right here in the output, it says we're logging to the console. Fantastic. And on this platform, the Cisco IOS, there are 7 levels regarding logging messages. There's 0 all the way through 7. And 7 is like the full details, all the details, everything. And as you go up to 6, 5, 4, etc., up at the top, they become the emergency and critical levels. So between 0 and 7, we have levels that represent notifications or interfaces going up and down, those types of things. So what this says here is that regarding logging to this console that we're currently looking at, the level is debugging. Effectively, it's going to say we're going to show everything right here. And in addition to doing logging right here at the console, we could also do logging to a syslog server. So currently I don't have a syslog server set up. We can fix that here in a moment. So here are some other examples of syslog messages. And if we scroll all the way up here, what we're looking at is logging that's happened to the actual buffer, which effectively means we're storing these log messages in memory as well. So somebody who's at the console will get the current messages. The buffer has all the messages based on how many syslog messages it'll store. And then we take a look at the output. These represent the levels. So that's a syslog level 5. Here's a syslog level 6. So here's a syslog level 2. And if we wanted to add a destination for a syslog server, on this platform, we'd use the command logging host, and then put in the IP address. Let's say it's 1111, press enter. And now if we do a show log, in addition to doing logging to the current console and also to the memory on the system, it's also going to send syslog messages now to that destination. And by default, it's not doing it level debugging, it's doing it level informational, but we could tweak that as well. And here's showing us the default protocol and port used by a syslog server. So we're going to send these log messages over to a syslog server at the well-known port of UDP port 514 to the IP address of 1111. And hopefully there's a syslog server over there who's happy and willing to receive those syslog messages. All right, so that's the logging on a local device. That's a router. Let's take a look at one other example. And that example is right here. It's a next generation firewall. And if we go to monitor, over on logs, we have lots of different types of logs. So traffic logs are reflecting all the traffic that it's logging. So I have some ping traffic and DNS, some Google traffic, and the action has been allow for all these. And if we click here for the word allow, and I look for deny instead and press enter, that's now showing me with that filter in place, it's showing me all the traffic that has been denied. So we could take a closer look at any one of those elements here in the traffic logs and identify why it was dropped. So the action was denied, and it was denied because of this rule in my security policy, which says no quick ports for Keith. And depending on the type of device, you may have other types of logs as well. So on this firewall, it has a special log category just for threats, where it identified a threat and it shows the details in the log files regarding those threats. Oh, look at that. And that's today's date right there. So let's just take a peek at that real quick. I'm curious. So this says that this PC was trying to go to that DNS server. That's an open DNS server on the well-known port of 53. So there's nothing too malicious about a DNS request. So the source port was 58,550. The PAT device changed that source port to 53,199, swapped out the source IP address to this IP address, which is globally routable. So that was the information about what was going to happen. Oh, and it did happen. So the action was just an alert. It wasn't a deny. So in this example, the firewall is warning us with the alert here that the user was trying to do a DNS request for a host name that was in the category of spyware. And so based on the policy, it said alert, don't stop it. But the firewall very well could have blocked that traffic as well based on the policies. Let's go ahead and click on close here. And here's yet another example where I was testing downloading a sample malware file. So down here, it's indicating that it sent an alert because there was a file, and then it saw that there was a vulnerability, so it actually did a TCP reset to both the client and the server. So the log files are going to help us identify what's going on, what has happened, and having centralized log files whenever possible is going to make it easier to correlate the log messages from multiple networking devices. And one element that can slow a person down as they're trying to go through a building is having multiple doors. Well, in the world of networking, each interface is like a door, especially for a router who's taking packets in on one interface, making a routing decision, re-encapsulating at layer 2 and forwarding. If we have a challenge or a problem with a given interface, we'd also want to know what to look for when we're looking at the details on one of those interfaces. So in the next video, I'd like to walk you through some general guidelines for working with and looking at interfaces of networking devices. So I'll see you there in just a moment. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.